Welcome to Shenzhen IO. This is a game brought to you by that company what made Space Chem and Infinifactory and some other games. I believe there's like a Steam Mech War 1 and like some kind of previous Alchemy 1 and other stuff. They make really cool, interesting little puzzly games. Shenzhen IO, you are given this operating system. Really, and I think you have to like make stuff. I don't quite really know. We have concept mail. All right. Welcome, dear new employee. Thank you for joining us. Shenzhen Long Electronics Company Limited. We aim to become a world-leading company in the electronics industry and security camera fake. All right. This product is an imitation mock security camera that has two blinking lights. Oh, this is my first job. Create a working design for the product. Okay. The first light blinks in a regular pattern. The second light is an internet light, so it should be blinking in a more random, intermittent pattern to resemble data upload. As you will notice, the design is partially completed already. A previous engineer quit before finishing the assignment. Note the timing diagrams in the verification tab. When you simulate, your output should match those expected values as indicated. Let the simulation run for full 4 tests. To make sure you have a proper solution. I'm absolutely certain you do better than the last person. Alright, create a working design for this product. Open it in Concept CAD. Create a working design for this product. Not yet verified. Okay, new design. Alright. Okay, I just had many designs. Alright, we'll delete the design. Okay, create a working design for the product. Open design. Alright. Fake surveillance camera. So, this game, stick with me, this is where it gets a little bit ropey. You have to design electronics, like circuit boards and all that kind of malarkey, and also program, like, the operating chips and stuff in, like, assembly language. Right. Honestly, I think it's going to be a good game. I've enjoyed all their games previously. I don't think this one's going to be any different, but just give me, like, 5 minutes of your time here, okay? Active and network a simple output connected to LEDs. Control the active and network outputs with fixed repeating signal as indicated in the verification tab. Okay. So the active just has to be on, off, on, off, on, off. And then this one has to be on, off, da 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 da. Okay. So that's my active and that's my network. So that's my LED for that and that's my LED for that. Okay, so what happens if we just, like, play this now? Move 0, P0. Okay, what if we simulate this? Okay, so active is working. Alright. Problem is, I don't actually know assembly language. But, we'll learn it here, eventually. Ah, so we do have data sheets here. Oh. Okay, that's... Oh, God. Okay, so it has minimized the game right now. It's opened up PDF files. We highly recommend printing this manual. For real? It's 41 pages. What? I have to... Oh, God, I have to assemble my own manual? I can't do that. I don't have a printer. Okay. I have downloaded the 41-page manual onto my iPad here, so I can actually play it right now and read the manual at the same time. Just scrolling through it here, I have letters from the CEO. I also have a visa application form for the People's Republic of China. I don't know if I'm playing a game or actually moving to China right now. So I've been reading the manual here a little bit. So this MOV is a move. I know a little bit of assembly. I've never actually like done anything with it. I just know like very basics of it. But anyway, MOV is move. So it's moving 0 into P0. P0 is this particular output here. It is then sleeping for a full 6 seconds. If we look at the verification here, system would be 1, 2, 3, 4, 5, 6. So that's measured in seconds, or milliseconds, or whatever. It's measured in 6 units of time. It's then moving value 100 to P0, 100 being the expected value here. It's going to P0 to go to the light here. And it's sleeping for another 6 seconds to be on. Okay. So, if we add in one of these and we take an output from P0 and connect it to the network light, and we type in some code here, we are going to mov 0 to P0. Yeah. We are then going to sleep for 4, mov 100 to P0, sleep for 2, mov 0 to P0. There's probably more efficient ways of doing this. That's kind of what this entire, like, Zachtronic Industries, or I think it's Zachtronics or something like that, the name of the company that makes these kind of games. The whole thing is about making things as efficient as possible. Right now, I'm just focused on making it work. So we're going to go sleep 1, then mov 100 to P0. So we'll probably be rated on the lines of code, right, and stuff like that. And then we are going to go sleep 1. I believe this will work. Ah ha ha ha! You see? So this guy here is sleeping and it's doing whatever it's meant to do. It is working! You've successfully completed 1 test run. Let the simulation continue running for all 4 to complete the verification process. Okay, so you see, there is a way to do less power usage. I don't know what power usage is. I'm thinking what power usage is going to be is having just one of these devices here. So what we're going to do, we're going to continue editing here. We are going to remove this guy, and we're going to go back to here. We're going to connect... I can't connect these two together? Okay, interesting. Alright, can I undo everything I just did then? Alright, thank you. So now if we go back, and we can just go, this design is a camera. Costs 6 yen, draws 60 power, but it's a camera, and it works. Congratulations everybody. Let's check our mail here. Yeah, thanks for your prompt work on the blinking lights. Looks okay. Alright, we have plenty more stuff to do. Our factory floor has some examples of older equipment that require control signals to be amplified. We had a device to adjust signals from this type of machine, but recently it was broken. Smashed. This is an appropriate project to teach you about inputs. Gee. Smashed. Hang on a sec. What happened? Is everyone okay? No need to worry. Okay. Right. We'll open in concept CAD here. We will open design. Alright, so we've got control in, we've got control out. Control in is a simple input connected to factory equipment. Control out is a simple output connected to other factory equipment. The signal from control in should be multiplied by 2 and copied to control out. Okay, so we're going to need one of these guys. And we're going to need to refer back to the instruction manual to work out how we amplify. Okay, so what we're going to do here, we're going to take our control in, we're going to connect that to P0. We are going to move P0 into ACK. ACK is basically a registry where we can store a little bit of information. It's just like the primary general purpose register, as it says here in my instruction manual. I just read that. I'm not going to make it up like I know what's going on. I just read that from the actual thing. We are then going to add P0. What add does, it adds whatever this value is, which right now is P0 to ACK. So that's going to add P0 to ACK. That's basically going to, oh no, you know what, really? We should probably just multiply. Yeah, no, we shouldn't, we don't know if it's going to be doubled. We don't know if adding it's going to be doubled. We should probably do a multiply 2. So multiplies this number here. It could be a register, it could be a number, by whatever is in ACK. Okay, we are then going to move ACK to P1. This might work. Hopefully. Part not sleeping. Okay, apparently it needs to sleep at some point. So I just added a sleep 1 at the end there, just so it sleeps for a little tiny bit. And it seems to be functioning. Whatever gets put in from P1, from control in, P0, gets put into the account, gets multiplied by 2, then gets moved to P1, and it seems like we're getting the right signals here, which is good. Our power usage seems to be fluctuating right around 240, which is not bad, and yeah. Nice. Return to email. Ding! Looks good, thank you, take care, yeah, sure. Ding, 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 so many dings, oh my goodness. Please enjoy a game. My daughter is learning programming. She created a simple card game. Would anybody like to try it and give some feedback for her? I put a link on everyone's desktop. She is interested in becoming a game developer. G. Win a game of solitaire. Okay, I will, I'll try. To, oh, it's like a Mojang solitaire, okay. Not Mojang, like, Mahjong, even. There you go. Alright, let's look at the instructions here. To win, stack 3 suits from 1 to 9 in the top right corner of the table. Okay, so we got bamboo, we got symbols, and we got targets. That's probably not what they are, they probably have proper names. 3 cells in the top left corner of the table can store 1 card of any type. When all 4 dragons of a single type are exposed, they can all be permanently moved to an open free cell by pushing the corresponding button. Right. Oh, I actually can... Okay, I get it. I can move stuff up to here. Right. So that moves the 2 up to there. This must be a dragon. Or are these dragons? What are these? I think they're dragons. I don't really know. Alright, we've got the 3 and we've got the 4 over there for those ones. I'm literally just playing solitaire right now. It'd be interesting if, like the jobs they came in, so you could just be playing solitaire, and then you would just have to get a job, and then you have to solve it in a certain amount of time. That would be interesting. It'd take away from the kind of puzzly thing of it, but it would certainly be interesting and fun to try. Can I move anything back down from any of these? I don't think I can. That's, I may have screwed myself over right now. Okay, let's do a new game here. Alright, well we got that, which is a dragon, presumably. I don't really know. I don't know why that's gone up there, honestly. I never thought I'd be playing solitaire on my YouTube channel. Oh, alternating suits and decreasing value. Okay, so I can stack stuff like that. That makes this infinitely easier. Okay, the problem is, you see what I've done now is I've blocked these 3 slots with these things. So I can never use those again, which is kind of an issue. But we might be able to work around it here. Okay, so what I think we're going to be able to do is nothing right now. Because I messed that up. Okay, right, so we've exposed all 4 of these dragons. If we whack this, aha, they get permanently moved up to there. So I can't actually use that slot anymore, but it does free up a whole bunch of numbers, which is fantastic. Okay, we are getting somewhere. Finally. Okay, we just need to free up this, or move this 8 to free up that dragon. So the way we are going to do that is by moving this 2. We can't move that 2 because we have to move that 8. So we're going to have to move this 8 onto a 9, or move it up to there. That would uncover 1, 2, 3, 4. So I don't know if it's going to break it or not. Right, because I can't move that one down now. Okay. So, we do have those 4 uncovered. I'm going to move this 3 over here so we can move this this 8 down to here. Then we can move everything up to there. Excellent. That's auto-completing a whole bunch. We are going to move this 7 onto here, this 8 onto here, move the 9. Ah, oh, really? No bounce? Alright, well I've won a game of solitaire. Holy man, that was actually really, really hard. Chinese, Chinese. Ah. I don't know what that says. If somebody can read that, that'd be fantastic. New part. An updated supplier agreement has given us access to a new part. The MC6000 microcontroller is much like pulse generator. In order to test some of our new manufacturing equipment, we need a pulse generator with certain requirements, specifications. However, instead of buying one at the market price, I thought we could simply create our own. For this project, we will need you to make use of conditional execution. Please continue your study of language reference G. Alright, open design. Button is a simple input connected to a button. Okay. Pulse is a simple output connected to an electronic device. When the button is pushed, generate pulses as indicated in the verification tab until the button is released. Okay, so this is going to be the button. We are generating pulse, 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 pulse. So pulse on, pulse off, pulse on, pulse off with a frequency of 2 seconds. Okay. That's basically what we're going for here. Alright, so we're going to grab... Oh, we've got some bridges, okay. I think we can get away with just using this guy, right? So we're going to put button as P0, and this is P1. Okay. It said we had to make use of something, 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 but I don't remember what that was. Okay, so what we're going to learn about is conditional execution. We are going to do a TEQ, which is a test. It tests for equals. That's T for test, E for, or EQ for equals. We want to test if this, okay, I know, you give me, I know, P0 is equal to, let me check the verification here, 100. If it is, then we want to execute anything with a plus next to it, which will be the set one. What's the set one again? MOV, yes. MOV 100 P1. Okay. Plus slip 1. Oh, hang on. 1. And then plus... Oh, you know what? We're always going to run MOV 0 P1. That's going to waste a little bit of power, but it's fine. And we're always going to run slip 1. So essentially what this should do is it will test if P0 is 100, so the button is pressed, at which point it will turn that on for 1 second and then turn it off and then leave it off for 1 second. It will then check it again to see if the button is pressed or still pressed. If it's pressed or still pressed, it will turn it back on. Reminder on my phone, don't worry about that. And then it will continue that cycle over and over again. This should work here. It wastes a little bit of power because we are going to be constantly running the turn off here. That would save a bit of power if we didn't run the turn off. And you know what? In fact, it shouldn't be a problem if we do put the plus there, because it's always going to turn it off after it turns it on. So that should be fine. Let's simulate this here. Yeah, there we go. Alright. So if the button is not pressed, it's just going to be sleeping for 1 second to check if the button is pressed again. When it is pressed, it does the whole wibbly 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 thing. So yeah, that's working there. And because it's not executing, it's executing the bare minimum of instructions, it should be relatively good for power at this point. Yeah, look at that. Super. So then this is where people were starting to do other stuff. I like that you get these graphs. I love these graphs that you get. So you can see like where other people are doing stuff. It's so beautiful. Anyway, return to mail. Yes, looks okay, suitable for our purpose. G. All right.